All right, guys, there's two problems left here. This is still lesson one, chapter one, lesson one. And these are the two problems kind of for the A students. And hopefully you're all sitting there thinking, wait, I'm an A student. But they're, push you a little bit and a little more tedious possibly too. The second one, not so much tedious, but this first one a bit tedious, but it kind of pushes you to put some things together. And so I want to go through this problem and show you this. We've hit the main concepts. We've hit the Pythagorean theorem. We've hit the distance formula. And now just to push you a little bit. So here's 3 points, -9, -2, and we've got a -1, -2, and a -9, 11. And the question is, if I graph those 3 points, would that form a right triangle? And there's a couple ways to approach this. One way, the easy way, it won't work every time, but it works in this problem. The easy way is to notice, wait a minute, these 2 points have the same x-coordinate. If they have the same x-coordinate, if you graph those, that's just going up and down vertically because they have the same x-coordinate. And you notice 2 other points have the same y-coordinate, meaning those are horizontal. If you have a vertical line and a horizontal line, of course they meet at a right angle. Okay? And so this one, just because of a little glitch in here, they had same 2 x-coordinates here, same 2 y-coordinates here. So yes, you got a horizontal line, you got a vertical line. These will form a right triangle. It won't always work out like that, and there's one on the homework, I believe, where it doesn't work out like that so nicely. So instead, there's another way to figure this out. And the way you would figure this out is you go way back and say, how do you tell if it's a right triangle? And the answer is, how do you tell if it's a right triangle? Remember the converse of the Pythagorean theorem? If a squared plus b squared equals c squared, then it's a right triangle. So we need to know the side A, side B, side C. But wait a minute. They don't give us side A, side B, side C. I'm just going to erase some of the lines on here. They just give us the points. So how would you get the distance between the points? Well, that's what we just did, the distance formula. So let's call this point A and call this point B and this point C. And let's find the length of segment AB. How would that work? Well, that's the square root, and let's subtract the x-coordinates. -1 minus -9 squared. Let's subtract the y-coordinates. Oh, how nice is that? -2 minus a -2 squared. And let's see if we can do a little arithmetic here. Minus a negative, remember that, plus a positive, a -1, a positive 9 gives you an 8. You've got an 8 squared minus a negative is plus a positive. That's a big 0 there. And at this point, hopefully you can do it in your head. 8 squared, and then I'm going to take the square root. Aren't those going to cancel out? A square and a square root, don't those cancel out? They do. Or figure out 8 squared. 64, square root of 64 is 8. So that side length is 8. That's AB. All right, that was fun. Let's do it again. Let's figure out BC. And what is that going to be? Well, square root distance formula, BC. And I've got a -9 minus -1 squared. I've got an 11 minus -2 squared. -9 minus a negative plus a positive is a -8 squared. 11 minus a negative plus a positive, so it's a 13 squared. Let's see, don't get fooled. -8 squared is a positive 64. 13 squared is 169. So what is that going to give us? 233. So the square root of 233, and that was, what was that? That was BC. So equals segment BC. All right, so much fun. One more time. Let's figure out AC. And let's see, AC here. We've got the square root. And I've got 11 minus -2. Square, oops, I did the y's first. Sorry about that. And I've got a -9 minus a -9 squared. So I've got a 13 squared. Remember the minus a negative? And here, look at that, minus a negative. I've got a big 0. So I've got the square root of 13 squared, which is 13, giving me segment AC. Okay, which of these are the short two? Well, it turns out, if you look through this or pull out your calculator, the 13 and the 8 are the short two. So now let's just try the converse of the Pythagorean theorem. Is it true that a squared plus b squared equals c squared? Let's try it and see. What's a squared? 8 squared. What's b squared? 13 squared. So I've got a 64 plus a 169. This looks kind of familiar. 64 plus 169 is that 233, which is c squared. So c equals square root of 233, which is exactly what we had right here. So the answer is, which we knew a long time ago, but the answer is yes, that truly is a right triangle. The method I showed you here, I know you're looking at it thinking, man, that was tedious, but it's also general. It would work in the cases where you don't have these nice matches on your coordinates. Okay, so that's a nice problem to kind of push you a little bit. Can you do the distance formula? Can you apply the converse of the Pythagorean theorem? And one last question here. Not quite as tedious, just a nice question. And you're going to have a homework problem almost identical to this. If maybe it is identical. I hope I changed it a little bit. We'll see. A 500-foot section of railroad track expands 6 inches because the day is very hot. This causes one end to break off and move upward, forming a right triangle. Find the height of this triangle. Okay, first of all, they don't make 500-foot sections of railroad track, and the reason they don't is for something like this, because 6 inches isn't a whole lot to expand, but if it ever did, it would be kind of disastrous. And if you think of railroad tracks or bridges or something like that, or even roads, they have those little gaps in the roads, and you can kind of feel the tar on hot days because it kind of bubbles up a little bit. So let's see what they're talking about here and see if we can make a triangle out of this. Here's a railroad track, and it's 500 feet long. Okay, what's going to happen on this warm day is it's going to expand by 6 inches, and we're going to assume it stays straight. And it just, at one end it's fixed, and it kind of pops up at the other end, is our assumption here. So this green one's our railroad track, except now it's 500 feet, 6 inches. And then we're also going to make kind of an assumption here when it pops up. It forms a right angle. And the question is, how much does that railroad track pop up? Okay, so hopefully, again, our assumption here is at right angle. So hopefully you look at this and say, oh, look, right triangle. I've got this, Pythagorean theorem. And you're right, you do have this. One little catch here, they mix up their units a little bit. Here it's feet, here it's inches. So you want to make sure you're using the same units. So probably easiest is take your 6 inches, and we know there's 12 inches in a foot. So 6 out of 12 is a half or 0.5 feet. So the 500 feet, 6 inches, I'm going to call that 500.5 feet because look, 6 inches is 1/2 of a foot. All right, let's apply the Pythagorean theorem. Let's go x squared plus the 500 squared, and that will equal the 500.5 squared. All right, I think we can pull out a calculator on this one, and it's going to turn out x squared. If I subtract the 500 squared, will be the 500.5 squared minus the 500 squared. And the first time I did this problem, it was, if you can tell from these books, it was a long time ago. These are old books. But the first time I did this problem, I had no idea the answer was going to come out the way it did. It came out much larger than I was anticipating it would come out. And let's see if you guys are at all surprised by this. So let's figure out here. Let's go with the 500.5. Let's square it. Let's subtract the 500 squared. And don't forget that that's going to be our x squared. We still have to take the square root of that. We'll get this part here. Let's get that answer. So 500.25. And now let's take the square root of that answer. And let's see here, we will want, I think we got a decimal there, so it'll give it approximation. So this track is going to pop up 22 feet. We switched this to feet. And again, that kind of surprised me. 22.3663 feet. 22, that's approximate, isn't it? 22.366 feet. So a railroad track expanding 6 inches, I thought it'd go up about 4 or 5 or 6 inches. It doesn't go up 4 or 5 or 6 inches. It goes up 22 feet by that expansion of 6 inches, which explains why they put all those gaps in the roads and in the bridges and things like that. If they didn't, it would be disastrous when things expand. So look for the problem very similar to that, hopefully not the exact same problem, on the homework. And that completes Lesson 1, Chapter 1, Lesson 1.